Hi, I'm Ryan. Our group T-4 recently had the opportunity to participate in Freshman Engineering Design Day 2017. Me and my teammates, Tom, Joey, and Jay, were tasked with designing and building a projectile launcher that was precise enough to hit a target 30 feet away. There was a list of constraints for the project, but the main ones were that the launcher must fit inside an imaginary 4-foot cube. The launch must be initiated by dropping a 5-pound weight. There must be at least 2 energy transfers inside the launcher, and we were to spend no more than $40 on the project. Our first idea for how we could get this done was by designing a Rube Goldberg machine type launcher because there were guaranteed bonus points for every energy transfer beyond the mandatory 2, but we stopped because of the potential energy losses. Our second solution was using a PVC air cannon launcher, but that idea was scrapped because of the high cost of PVC and PVC glue considering our budget. The next solution, which led to our final solution, was a crossbow launcher, but we changed that because we couldn't decide on if it gave us the necessary amount of energy transfers. But finally, we decided on building a slingshot launcher by using a bungee cord, a breakaway buckle, and rope. The idea was that when we dropped the weight, the bungee cord would be drawn back like a slingshot, then released, launching our projectile.
Hi, my name is Tom, and as Ryan just said, we went through many different brainstorming sessions to make sure that our project was able to perform within the design parameters, as well as meeting the goal of launching 30 feet. And so we built a prototype and modeled our design off of that, and improved upon any flaws that happened to the prototype so that they didn't occur in our actual model. And then we had to solve various different design challenges, such as how to get the weight to be pulled back and make sure that we did so with the most momentum when the ball launches. And we also had to figure out how to make sure that the breakaway didn't prematurely break and launch the ball before the weight actually dropped all the way back. So to do this, we used double-sided tape for the breakaway so that we'd have a delayed response time. And then to get the weight with most momentum, we installed a back pillar and then 2 pulleys so that the paracord would be tied to the breakaway, which was also attached to the bungee. It would be pulled back, run through the bottom pulley up to the top, and then the weight would pull back. In the next 2 videos, you can see how this has worked.
My name's Joey Franzalia, and I'm going to cover the performance of our precision launcher at the Freshman Engineering Design Day event. When we got there, we checked in and were directed to the precision launcher designated area, and that's where we set up our launcher and our poster describing the entire process of designing, creating, and testing our project. We were the third group to go, so we brought our launcher up to the 30-foot indicator marks, and we were asked a series of questions about our launcher before we were cleared to launch it, about how we chose to incorporate certain elements of the launcher and why we chose to build it a certain way. So the first of our 3 attempts was the most successful. However, it was still unsuccessful, with the projectile only traveling about 15 feet and bouncing the rest of the way. The second attempt was unsuccessful, and our projectile did not travel any distance. Rather, it fell to the base of the launcher due to a malfunction in the hooking part of our breakaway buckle that involved a complete separation from the rest of the mechanism. We tried to fix the hook in the middle of the launching by applying duct tape to the base of the hook and around the projectile's holder, and also by placing an adhesive between the 2 of those, but unfortunately the third attempt was also unsuccessful because the adhesive did not hold in the entire breakaway buckle, and the projectile's holder detached from the bungee on which they were attached. The projectile did, however, travel like 5 feet rather than completely failing. Our launcher performed worse than we expected at FEDD we have a few theories as to why that was the case. In the days leading up to FEDD, we put it through a lot of mechanical stress through the process of adding the finishing touches to construction and adding to certain elements while changing other elements and repeatedly testing the launcher. We believe that the testing put a great deal of stress on the hook, and that is a large reason as to why it broke so easily in competition. Whatever the reason was, FEDD Day taught us important lessons as to what is necessary to ensure project performance, and we'll be sure to utilize that knowledge in the future.
Are a couple of things that we would definitely do differently the next time around. Firstly, we could have made a more sturdy holder for the projectile than a plastic bottle. I feel like if we would have simply put in a little bit more effort, we would have easily been able to design a wooden holder, and it would have been significantly more durable, of course, than plastic. Secondly, we could have used a more enduring glue or a stronger glue than just hot glue to keep the holder and the bungee cords together. Again, this would have been much easier if we had a wooden holder. The plastic hooks that we used were also not the best choice. They could have definitely been replaced with like aluminum hooks or steel hooks. We also could have simply made another holder for backup, another plastic holder for backup, which would have definitely worked in our favor since the plastic one had worked so fine during the testing phase of our project. Now, the advice I'd like to give freshmen is that when you're building something, don't let the fact that it's only going to be used once make a huge impact on deciding your materials. Build it like it's meant to last. Thank you.